Hi, and welcome to Online Appliance Tech. Today we're going to go over the Whirlpool Ice Maker Diagnostics and Troubleshooting. So we'll go over the emitter board, Ice Maker Harvest Test Mode, also the water valve, and the sequence with this switch which could cause the problem also. So watch this till the end. So this is the emitter board. If you do have one of these in your refrigerators, this will be your first test. So make sure you have it in the on position, and then you have a beam that shoots across that hits this part, where it allows it to know when the ice is full or not. So if you shut this flap and make sure you don't block it with your hand, this side should be a solid light. If that's the case, you have a good emitter board. So say if you hold this flat and don't block it with your hands and then it's blinking twice and pausing, this means your emitter board thinks the ice maker is full or just basically not corresponding, which it will then not harvest ice. But as you can see here, this is a good one. So we'll move to the next test. To remove this, it's pretty simple. Make sure you unplug it, and you'll remove these 3 screws, and I believe there's 2 on the other side, and just disconnect the harness and put it back in its place. So here's the part you would need if this was defective. I will leave this in the description below if you do need this part. Fairly simple to install, and you can find many other videos to install it. So say if your ice maker is not making ice and it's dripping to the bottom, well, that's pretty simple. That's just going to be your ice maker, and I will leave a video at the end of how to replace it. So to remove this, well, this is a built-in, so I had to take it down. So other refrigerators are much easier. You don't have to remove it just to pop this off, but I did just for training purposes. So you'll pop that out with your flathead, and here's sometimes they have information inside this little cap, but this one they don't. So first thing, we're going to make sure we have power coming into the ice maker. Now if you do have an emitter board, you will not have power at this point because the emitter board is what gives this power. As you can see here, we have no power. So if you do have the emitter board, it will come from the emitter to the door switch and to the main power source inside to the housing of the fridge. If you don't have the emitter board, it will just be from the door switch to the power point of the housing of the fridge. So if I do know I'm getting power from the main point or the housing of the fridge, I'm going to check the voltage to the ice maker itself. So I will connect it from my L to my N, which is my live and my neutral. I have to shut the flap, make sure the light is solid. Okay. Now this will blink if it's in harvest mode, which at this point it's not. So it's solid. I'm going to hold the door switch down, and then as you'll see here, we'll shoot 120 volts here in a moment. So there we go, 120 volts. So that tells me that the emitter is doing its job, the door switch is working fine, and obviously it's all the same. Here's an ice maker. You can just pull the cap off the top of them and do all these tests without removing the ice maker like I had to. So they're all the same type ice makers and easy to get to, and you don't have to remove them to test them on these like this. So once the harvest mode is activated, you cannot stop it. It will run its cycle. So even though if you try even to turn the emitter off, it's still going to run. But at this point you can do a test. You can check the water inlet valve by putting it in the neutral and the V. And when it shoots for water, and have a cup or towel ready because it will shoot up water if you have to remove it. As you saw earlier in the video, the other ice makers, you just let it fill up into the ice maker itself. So you will get like 100 to 120 volts. If you don't get the voltage output, that means your ice maker is bad and not sending a signal to the valve. If you do get voltage output and you have no water, more than likely you have a bad valve. So say if this is just a basic ice maker with no emitter board. So for example, we'll put it in, or N or L, we should have 120 volts, especially if we hit the door switch down. If we don't get power, then we can check the door switch. If the door switch is good, more than likely it's your main control board. So just to recap, you will check the L and N for power, and then if you don't have power, which should be 120 volts, shut the door switch. You should have it. If not, then check the door switch. So now we're going to test the ice maker, and we're going to show you how to jump and start the harvest. And we can also check the water valve, which could be a reason, or the ice maker even the door switch, and we'll do this with the 2 wires. So they have to be insulated, so make sure they are insulated and just trim out the edge. So your V and your N is your water valve power output from the ice maker to the valve. So to start this activation, you're going to jump your wires from T to H. As you can see, they are insulated. I just trimmed them off at the edge, and you'll see it will start to harvest. And the reason I was able to do this with this unit, because it still had signal from the emitter. If you don't have an emitter, you can just close the door switch if you had to, but even on those, I don't even think you have to. So you should get 120 volts once it asks for water. So say if you do jump it, the T and the H, and you have no activation, it's not doing nothing. So at this point, it could be the emitter, door switch, or your main power control board or source of power, which is usually the main control board. So here's the ice maker that was in the previous part of the video. I had to replace because the motor was defected. I will show you how to test and basically just break this thing down to show you what really happens inside the ice maker and all the parts. Sometimes you can just replace this front housing, but you're better off just replacing the whole ice maker just for corrosion and other things. So this thing just pops right off, and let me slide it off. There we go. So yeah, this is the motor. So has a winding. It should be like 4,400 ohms. This one was way off once I tested here later on in the video. This is your thermostat. So this is what allows power to go from the H to the T. So that's why you can just jump that to make that work. And then here's your heater, 72 ohms. And this is a little switch. You can make your cubes smaller or bigger just by turning this. So let me go ahead and take these off, and I'll show you exactly how the thermostat and where the heater is located. Pretty much though, this is just for tickles and giggles, I guess. Better off just replacing the whole ice maker. I just wanted to show you exactly how it was made. So this is the thermostat. Once it gets cold enough, it does transfer the power to harvest the ice. So this is how it controls the harvest. So it has to be obviously cold enough to harvest the ice, and this is what tells or allows it to harvest, if that makes sense. So yeah, just like a little bimetal thermostat. Here's the where it sits against the housing of the ice maker. So once it freezes, it'll know. And this is the heater. This is embedded. So this should be around 72 ohms. So if you have a bad heater, and a good thing is you can check all this from the front of the ice maker itself. You don't have to take it apart to test. So that's the amazing thing about this. So right here, I'm going to go ahead and test the motor itself. As you can see, you can actually test this on the other side. You don't have to take it apart. But just to show you, I guess over time they get a little, see the 64,000, not 64,000, 6,400, and it should be 4,400. So that was a problem. So I hope this video was helpful. Please like and subscribe for more future tips and videos. Have a good day.